one we will cover. Today we will see what is radar system, what is radar range equation, and this radar range equation can be expected as a essay mark question, which we are observing in previous year question papers. And first we will see what is radar. What is the full form of radar? The full form of radar is radiation of detection and ranging. The full form is radio detection and ranging. Means the radio signals from transmitter to receiver side, it is detecting. This whatever the radar signals we are using, there we are using electromagnetic signals. And these signals, to this electromagnetic signals, we are detecting from target. What is the meaning here? Whatever the radar full form is radiation detection and ranging. It is an electromagnetic system. It is used for locating the objects. Here, what is the meaning of objects? Here, the location of the objects means here we are locating the target material and we are finding the distance between the target material from the antenna is called as radar range, and here what we are calculating the distance, or we also can say that we are calculating the ranger. So radar system is used for from where to where? This radar system we are using from transmitter to receiver side. This transmitter to receiver, whatever the signals we are passing, the frequency of the signals is in terms of gigahertz frequency. So with signals, suppose here I have transmitter. Other side I have receiver. I am sending signals from transmitter to receiver. Whatever the signal frequency we are using, the frequency is in terms of gigahertz. The signal frequency is in terms of the gigahertz. For transmitting the signals from transmitter to receiver, in between I am using the term called antenna. For transmission of the signals to the target element, what we are using? We are using antenna. When the radio frequency signal strikes the target material, again it is reflecting back. Suppose here I have antenna. Imagine this is antenna. I am sending input signal. Whenever the signal is passed to the antenna, again it is reflecting back. So this is the signal, whatever we are sending, this is called as transmitter signal. Again the signal is returning back. Whatever the signal is returning back, this signal is called as a reflected signal. So two types of signals. Whenever the signal is passing to the input, signal is passing to the antenna, is called transmitted signal. When it is returning back, the signal is called as reflected signal. So when it is reflecting the signals, there is some disturbance in the signal. That disturbance, whatever we are passing across the input, the same thing is not coming to the output. In the output, we are getting noise in the signal. That noise, the term is here I am calling as the echo signal. So using these radars, we are determining the distance between the target material from its initial position. Using this radar, what we are doing, determine the distance to the target, and we are also calculating the position of the radar system. Also, angular velocity, radial velocity also be calculated. Here we will see the what is basic radar system. The first topic, this is introduction. So in introduction, what we discussed the full form of the radar, radio detection and ranging. Here we are using radio frequency signals. The frequency we are using for transmitter to the receiver is what? Gigahertz frequency. Whenever the input signal we are transmitting to the antenna, that signal is called transmitted signal and it is reflecting back. The reflecting back signal is called reflecting signal. When it is reflecting back, we are getting some noise or disturbance in the signal. That is called as the term echo. Next, we will see the basic radar system. In basic radar system, we have two types of radar systems. What is the first one we are using? The first one is bistatic radar system and the second one is monostatic radar system. This radar system, here I am using the term transmitter. Transmitter means which we are sending from input side, transmitter, and across the output side I am calling as the receiver. So first, which topic we are discussing? Bistatic radar system. In bistatic radar system, we have two antennas separately for transmitter as well as receiver. One antenna, this is the first antenna. This first antenna is used for this antenna is using for which one? transmitter. Next, second antenna, another antenna also used here. This second antenna is using for which purpose? For receiving of signal. So two antennas are used. One is for transmitting purpose, another one is for receiving purpose. When the first signal we are transmitting, where it is going, this signal? The signal is going to the target material. The first signal, whatever I sent, this is going to the target material. From target material, again it is coming to the which side? It is coming to the receiver side. Transmitter to the signal is going to where? Antenna. From antenna, the transmitted signal is reached to the target material. From target material, again it is retrieving back. In case of retrieving back, the received signal is passed to which side? It is passed to the antenna. From antenna, it is reaching to the receiver. So the final conclusion is, in bistatic radar system, the main thing is we are using true antennas. What we are using in bistatic radar system? In bistatic radar system, we are using two antennas. The first antenna is transmitting antenna. The second antenna is receiving antenna. Now we will see what the information is covered in this before going to the monostatic. We will see the introduction of what is mentioned in this. Bistatic radar system consists of two antennas. What is the first one? Transmitting antenna, and that is what? Receiving antenna. Next, the transmitter antenna transmitting with signals. Here with signals it is transmitting. Electromagnetic signals is transmitting. A portion of the electromagnetic signal is transmitted, is collected by the transmitting antenna. From there it is reached to the target material. After reaching to the target material, again it is redirected. What is the here meaning of redirection? From the target material, again it is going to the receiver side. That is, what is the function of receiver antenna here? The receiver antenna receives the echo signals. Means whatever the target is sending again back, it is getting. But what we are getting in this receiving signal? We are getting not pure transmitted signal. We are getting echo signal. So finally what we have to do? We have to process the echo signal at the receiver to detect the presence of target, and we have to find out the position. Range meaning is distance. Also we are calculating radial velocity of the target. Up to this is the explanation for bistatic radar. Next, another one we have. What is the second one subheading? The second subheading is monostatic radar. Is antennas is here? Just cross check, is antennas is here in this monostatic radar system. In monostatic radar system, we are using single antenna. Whereas in bistatic, how many antennas is used? Two antennas is used. But here we are using single antenna. How the process is going on? Transmitter to, it is going to the duplexer. From duplexer to, it is going to the antenna. After antenna, again it is reflecting back. It is reflecting back to the receiver. How it is reflecting back to the receiver? From antenna to the duplexer, duplexer to receiver part, it is going on. So first like this. Next, from here, it is coming back to the receiver. So here in the who is the mediator here? Mediator is duplexer. What is the meaning of duplexer? Duplexer allows the transmitter and receiver signal for the single antenna to means both transmitter and receiver both are sharing the single antenna using which one? Duplexer channel. The duplexer allow the transmitter and receiver to share a single antenna. By using single antenna, what is the advantage? It is prevents high power transmitted signals. So if whatever I sent from the transmitter, it is going to the antenna. From receiver antenna to it is receiving back. By using duplexer, what is the advantage? High power transmitter signals are prevented. Which signals are preventing by using duplexer? High power transmitter signals are prevented from in the receiver. If we are getting high powered signals, what happens? The receiver can be damaged. So the transmission of electromagnetic signal, the duplexer connects the transmitter to the antenna. Suppose I am using only transmitter channel. So anyone is connected out of these two, anyone is connected to the duplexer. Suppose I am transmitting. What is the role of receiver at the time? Receiver is in disabled condition. Only one is working. Either transmitter is working or receiver is working. Suppose transmission of signals to the duplexer to the output. At the time of transmitter, receiver is disabled. Suppose receiver is working. What happens to the transmitter? Transmitter is disabled. Only one is working. If transmitter is connected to the antenna to the duplexer, receiver is disabled. Suppose receiver is connected to the antenna, transmitter is disabled, which is explained in this paragraph. Next, finally, what we are calculating, whatever the signal we received, echo signal, whatever we received across the receiver, we are calculating its position. Also, we are calculating its range and we are calculating its radial velocity. In both the cases, also we are calculating in monostatic and bistatic, we are calculating the position, range, and radial velocity. These calculations is common for both bistatic and monostatic. Next, we will see how to measure the range, calculation of the range. To calculate the range, here the range is represented with R. What is R? Here R represents the range. So, for traveling from the target to the receiver, suppose here I have antenna, this side I have receiver. So, antenna నుంచి ఎక్కడికి వస్తుందమ్మా? Duplexer, antenna to duplexer, duplexer to receiver. This is receiver, this is antenna. So whatever the distance it is traveled is 2r. How much distance it is traveled means 2r distance it is traveled. Next, what is C here? C is the velocity of the electromagnetic wave. Using this, I am calculating the time period. What is the time period here? The time period is distance by velocity. How much distance it is traveled means here what we will tell how much distance traveled. It is traveled the distance of 2r. And what is the velocity of time? Here the velocity of light I am taking as c. So here how we are writing equation t equal to 2r by c. From that calculate r value. What is r? Adjusting the terms, what will get the value of r? R equal to 2c by t. T equal to formula. What we got? T equal to 2r by c. Cross multiplication and calculate r value. R value equal to ct by 2. As time period and frequency are reciprocal. So in terms of frequency, how we have to write? R equal to C by 2 times of F, if it is in terms of frequency. So here how we will get the signal? We will get which type of signal is working here. Here the signal is pulse reception time. And the signal is actually, we know this is square wave. Is it? This is square wave. In this square wave, again, in this square wave, I will represent this as 0, this as 1. Again, this is 0, this is 1. This is 0, this is 1. In this square wave, whenever the pulse is high, in that we have sine waves. Sine waves. Again, 0. Across 1, I have sine wave. Again, across 1, sine wave. So sine and pulse both combination. Sine and pulse both the combination. Whenever the pulse is high, at that time which wave we have? Sine wave. So I am calling this wave as a pulse modulated sine wave. Why it is called as pulse modulated sine wave? In between which wave we have here? Here sine wave. Overall outer structure is in terms of pulse. So finally it is called as pulse modulated sine wave. This is 1. Whenever it is high, this we will treat it as 1. Whenever it is 0, this is treated as 0. Again, this is 1. This is 0. This is 1. This is 0. So this wave is called as pulse modulated wave. And total time period, on period and off period. How to take on period and off period of the signal wave? Suppose I have signal like this. This period is called as T on period. Whatever the on time I am calling T on. Suppose this is low. This is called as what? T off on. So total time period TP equal to on period plus off period. Total time period is equal to on period plus off period. Total time period here we can take on period and off period. Suppose I have signal like this. Signal like this signal is there. To this signal, this on period is T on. Where is this off period is called as T off. So total time period TP, what we will call total time period TP is T on time plus T times of off time. T on period plus T off period. And what we got formula for this range equation? What formula we got for range equation? R equal to what we got range equation? Range we got R equal to time period velocity by 2. In terms of frequency, I am writing R equal to C 2 times of F. Here, this F I am representing as a F of P. F of P. This time period I am calling as a TP. What is TP? Pulse time. What is the form of P? Pulse time. Pulse frequency. What is FP here? Pulse frequency. This is about what we discussed. This is about basic radar system. Next topic we will see radar range equation. What is the next topic we are discussing? Radar range equation. In radar range equation, next topic we will see radar range equation. Here we calculated. Next is radar. Second topic. We will see radar range equation. In radar range equation, we can this expect as a essay question from this block. We can expect this as a essay question. Here I am calculating power. Power I am calculating. Whatever the power I am calculating, that is again across the transmission side, again across the receiver side. And now first we will see the transmission side power. Next we will see the receiving side power. First what we have? P1. What is P1? P1 is power density. P1 equal to first equation we have to write. What is this first equation? What is P1? P1 means power density. What is PT? PT here is peak pulse power. Here we have. What is PT? Peak pulse power of the antenna is PT. And R is the range. So finally what I am writing? P1 equal to PT by 4 pi R square. This is first equation number 1. 4 pi R square. What is P1? Power density. P1 equal to power density PT by 4 pi R square. Similarly, for this what I am doing? I am multiplying gain. What is the gain here? AP is the gain. I am multiplying to the first power gain and writing as the second power density. What is second power density formula we have? First power density is Pt by 4 pi r square. Whatever we have for Pt by 4 pi r square, to that one, I am multiplying the gain AP. AP gain is multiplied and I got second equation. To this one, I am multiplying again the radial cross section. Effective area is rho. Same P2 కి రో మల్టిప్లై చేయాలి. P2 ఏముంది? PT by AP by 4 pi r square ఉంది కదా, దానికి రో మల్టిప్లై చేయాలి. రో మల్టిప్లై చేస్తే ఏమొస్తుంది? థర్డ్ పవర్ డెన్సిటీ వస్తుంది. చూడండి, వాట్ వీ హ్యావ్ హియర్ P2. వాట్ ఇస్ ద డిఫరెన్స్ బిట్వీన్ P2 and P3? PT we have, PT we have. AP, AP. To this PT AP by 4 pi r square, which what I multiplied? I multiplied rho and it is called as a third power density. Next, so P1, P2, P3. We wrote three equations. Three power densities rasam. Em rasam? P1, P2 rasamu, P3 rasam. This P1, P2, P3, both is comes for the transmitter. Both is belongs to which one? Transmitter. Now we will write for the receiving section. For receiving section, the power I am calling as a P4. For receiving section, what we will call power? P4. What is the P4 formula? P3 by 4 pi r square. So substitute P3. What is P3? The above equation we will substitute and we will get this equation. After getting fourth power density to this one, I am multiplying gain across the receiver side. Gain across the receiver side is P5. We will get this equation. So we will write this. See, this one is step by step in board. Yes. What is PT? In this radar range equation, what is PT? Peak pulse power. Peak pulse power. Peak pulse power. From this, I am calculating P1. What is P1? Equation P1 equal to PT by 4 pi r square. PT by 4 pi r square. PT by 4 pi r square. Again, to this P1, I am multiplying the gain factor. What is gain? Here gain, I am taking gain as AP. So, to the first equation, I am multiplying gain. Now, how to multiply? After multiplying gain, what we will get? P2 will be occurred. So, what is P2? P2 equal to PT AP. Gain I am multiplying by 4 pi r square. We got P2. Next, multiply with area of cross section rho. With what you have to multiply? Multiply with area of cross section. After multiplying with area of cross section, after multiplying area of cross section, I will get P3. What is P3? PT, peak pulse power PT times of gain AP rho by 4 pi r square. So whatever P1 we calculated, P2 is calculated, P3 is calculated. These three is for whom? These three is for transmitter. These three is for transmitter. Now I will go for the receiving section. In receiving section, I am using P4. What is receiving section? First term we are using P4. What is P4? P4 equal to P by P3 4 pi r square. Substitute P3 value. What is P3 value from previous equation we got? From previous equation, what is P3? P3 equal to PT, AP, gain area of cross section by 4 pi r square. This is P3 by 1 by this P3. This P3 I substituted here. This P3 is substituted here. Again 1 by 4 pi r square is writing as it is. After writing 1 by 3 4 pi r square, what is the equation we will get? After multiplication, final equation, what we will get? PT AP rho by 4 pi r square whole square. Whatever we got, this is power 4. After getting power 4, to this one, I am multiplying with area of cross section. After this, I am multiplying with area of cross section AE. So next is what we am writing P5. P5 equal to P4 times of area of cross section AE. Now AE, after multiplying with AE, what will get P5? P5 is equals to P4. Right as it is. What is P4 we got? PT times of AP rho by 4 pi r square whole square times of, here I am multiplying the above equation with AE. After multiplying here, after multiplying, I am treating as power is minimum. If power is minimum, range is maximum. If power is minimum, range is maximum. So to the same above equation, I am writing P of minimum value is equals to same above equation. You write again. PT, AP, AE, rho by 4 pi whole square. This r square I'm writing as r to the power of 4. This power is minimum, r is maximum. Treat r equal to maximum. So final conclusion is P is directly proportional to r to the power of 4. Here P value is minimum, r value is maximum. So we got r. So LHS, what we have in LHS, we have P minimum. In RHS denominator, I have R maximum. Now I am writing equation only in terms of R. Rearranging the terms. What we will get rearranging the terms? R is equals to PT, AP, AE, rho by 4 pi square times of P of minimum value will get. So this is the value of R maximum value. After calculating R maximum value, we have one relation. What is that relation? Is AP equal to 4 pi AE by lambda square. This equation you substitute in this. Where you have to substitute? In place of AP, you substitute. After substituting in place of AP, we will get final equation. That final equation is what? After substituting, we will get one final equation. This is the final equation we will get after substituting. This is the R. So this is radar range equation. So in radar range equation, we will recall once again what we did. In radar range equation, first we wrote P1 value. After writing P1 value, next what is written? P2 value is written. How we got P2 value? To the P1 value multiply gain. P1 కి ఏం చేయాలి? AP gain ని మల్టిప్లై చేస్తే P2 వస్తుంది. ఆఫ్టర్ దట్ ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ని రో మల్టిప్లై చేస్తే ఏమొస్తుంది? P3 వస్తుంది. సో P1, P2, P3 is for transmitter part. Next for the receiving part, you will get 2 P4 as well as P5. So receiving part to P4, P5 after reaching, I am giving a conclusion that if power is minimum, range is maximum. From this, I am bringing calculating final value of R maximum. So this is the fundamental form of radar range equation. 18.10 is a fundamental radar range equation. And next we have in antenna theory, we have one relation between AE and AP. What is the relation between AE and AP? That relation we have to substitute. What is AP? AP equal to 4 pi AE by lambda square. After substituting, we are getting final equation and write individual terms. What is PT in the above equation? Peak power transmitted. What is the lambda? Wavelength. What is AP? Power gain. What is AE? Power gain of the capturing antenna, receiving antenna. P is detectable power, which is minimum. So after writing this, the continuation we have pulse radar system. In the radar range equation only, we have pulse radar system. What is explaining in the pulse radar system? Now next we will see pulse radar system. In pulse radar system, this is the block diagram of pulse radar system. Here what we have, which is input, which is output, how and how it is working. This part is transmission part. This part is receiving part. Which is transmitting part? This is transmitting part. This is receiving part. In transmitter parts, what I am using? I am using pulse modulator. Pulse modulator. Pulse modulator nunchi pulses vastayi. That pulses to where we are feeding those pulses? I am feeding those pulses to the transmitter. From transmitter, where it is going? It is going to the duplexer. From duplexer to it is reaching to the antenna. From antenna, again it is coming to the receiver section. Now we will see that one. First, pulses. Input pulses. Input pulses నుంచి ఇట్లా వస్తుంది. So what is our input signal? Square with sign combination. The input is which one? Square. ఎక్కడైతే 1 ఉంటుందో ఇక్కడ సైన్ పల్సెస్ ఉంటాయి. ఎక్కడైతే 1 ఉంటుందో ఈ 1 లో మనకు సైన్ పల్సెస్ వస్తాయి. Square with sine pulses. Those pulses to which I am feeding? Those pulses I am feeding to duplexer. Duplexer నుంచి ఎక్కడికి వెళ్తుంది? Antenna. From duplexer to it is reaching to the antenna. So this is first part. Again in the second part, from antenna to it is coming to the low noise radio frequency amplifier. Across low noise frequency amplifier. Next what we have? Mixer. ఇక్కడ mixer ki 2 parts is attached. What are the 2 points attached to the mixer? One is local oscillator is connected. Another one is low noise radio frequency amplifier. These two are connected to the mixer. From mixer it is connected to intermediate amplifier. From intermediate amplifier it is going to where? Detector. I will enlarge the diagram. From there it is going to the detector. From detector to where it is going? Video amplifier. From video amplifier to the display. Now we will see internal functioning of each step by step. So pulse modulator is producing pulse. The transistor consists of microwave oscillators such as magnetron. This magnetron is on and off, means here we are getting pulses. From where we are getting pulses? We are getting pulses from the magnetron. This pulsed sine wave is traveling to where? Duplexer, to the antenna. Duplexer నుంచి ఎక్కడికి వెళ్తుందమ్మా? Duplexer to antenna. And it is radiated into the space. After radiating into the space, again it is sending back to the receiver. So first part is completely transmitter part. What is the next part? Next part is receiver part. So the duplexer is already explained. Duplexer serves as a channel. Manaku output lo em vastundi? Disturbance vastundi, echo signal to the receiver. So duplexer here, this duplexer here consists of 2 gases. One gas is called as transmitter and receiver. Discharge devices antam anamata. The duplexer is producing 2 gases. Here duplexer is producing two gases. One gas or discharge devices. What are the two discharge devices? One is transmitter receiver, another device is anti-transmitter receiver. So this transmitter receiver, another one is anti-transmitter and receiver. These two acts as a switch. How these two acts? These two acts as a switch. These two is acts as a switch. So this, what is the function of TR? TR protects receiver. ATR protects transmitter. Next, we will see what happening. Rough diagram I will explain here. Transmitter section. Transmitter నుంచి ఎక్కడికి వెళ్తుందమ్మా? Transmitter to duplexer, duplexer to antenna. From antenna again it is coming back to the duplexer. Duplexer లో echo signal ఉంటుంది. That echo signal is connected to mixer. Mixer ki రెండు connections ఉన్నాయి. How many connections we have for the mixer? Two connections. What are the two connections we have? See here. This is mixer. To this mixer. One is radio frequency oscillator. Low noise radio frequency amplifier ఉంది. ఇంకొకటి ఎక్కడ ఉంది? Local oscillator ఉంది. Radio frequency amplifier ఉంది. ఇంకొకటి local oscillator ఉంది. సో ఈ రెండిటి నుంచి మనము లోకల్ ఆసిలేటర్ ని మనం యూజ్ చేసే ఫ్రీక్వెన్సీ ఎఫ్ఎల్. ఇన్పుట్ సిగ్నల్ లో మనం యూజ్ చేసే ఫ్రీక్వెన్సీ ఇక్కడ ఏంటి? ఎఫ్ఎస్. హియర్ ఐఎమ్ యూజింగ్ ఎఫ్ఎస్, ఎఫ్ఎల్. ఆఫ్టర్ యూజింగ్ ఎఫ్ఎస్ అండ్ ఎఫ్ఎల్, what is the output is appeared? The output is fs plus fl, fs minus fl is appeared across the output. ఇక్కడ మనకి రెండు వచ్చాయి కదా, ఇక్కడ నుంచి అవుట్పుట్ డ్రా చేస్తాం. ఇక్కడ నుంచి అవుట్పుట్ డ్రా చేస్తాం. వాట్ వీఆర్ గెటింగ్ అవుట్పుట్? సోర్స్ ఎఫ్ఎల్, లోకల్ ఆసిలేటర్ నుంచి ఏమొస్తుందమ్మా? ఎఫ్ఎల్ వస్తుంది. ఒకటి ఎఫ్ఎస్ ప్లస్ ఎఫ్ఎల్ వస్తుంది, ఇంకోటి fs minus fl. So this fs plus fl, fs minus fl, these are the output of the mixer. ఎక్కడి నుంచి వస్తాయి? These are output of the mixer. Again, output of the mixer is connected to where? Intermediate amplifier. The output of the mixer is connected to intermediate amplifier. From intermediate amplifier, again it is going to detector. Detector నుంచి video amplifier. Next is final display. You have to explain this one. So mixer నుంచి intermediate amplifier. Intermediate amplifier ఎక్కడికి వెళ్తుంది? డిటెక్టర్. డిటెక్టర్ నుంచి వీడియో యాంప్లిఫైర్. వీడియో యాంప్లిఫైర్ నుంచి డిస్ప్లేకి వస్తుంది. ఇందులో మనకు చిన్న డెరివేషన్ పార్ట్ ఉంది. వాట్ ఈస్ దిస్ డెరివేషన్ పార్ట్? Radio frequency amplifier signal. What we are getting? Vs. Vs equal to volt here. Vs equal to capital Vs sin omega st we are getting. From local oscillator I am getting VL equal to VL sin omega LT. These two are multiplied. Output voltage V0 equal to Vs into VL. We have one formula. Cos C minus cos D. What is cos C minus cos D? Cos C minus cos D ఒక ఫార్ములా ఉంది. 2 sin C plus D by 2 sin C minus D by 2. So sin C sin D. 2 sin cos C minus cos D equal to 2 sin C plus D by 2 sin C minus D by 2. సో ఓన్లీ సైన్ టర్మ్ తీసుకొని మల్టిప్లై చేస్తున్నాను. చూద్దామా ఫార్ములా ఇక్కడ రాస్తాను. వాట్ ఈస్ cos C minus cos D. ఏమొస్తుంది ఫార్ములా 2 sin C plus D by 2. 2 sin C plus D by 2. ఇంకొకటి sin C minus D by 2 వస్తుంది. సో ఈ 2ని ఈ 2ని LHSకి తీసుకొస్తున్నట్టు 1/2 టైమ్స్ అవుతుంది. 1/2 టైమ్స్ ఆఫ్ కాస్ సి మైనస్ కాస్ డి. ఇది ఇక్కడ ఫార్ములాతో వచ్చింది మనకి. ఇక్కడ చేస్తే కాస్ సి మైనస్ డి సి ప్లస్ డి వస్తుంది. ఒమేగా ప్లేస్ లో ఏం పెడుతున్నాం 2πf సబ్స్టిట్యూట్ చేస్తున్నాం. ఒమేగా ఎస్ ప్లేస్ లో 2πf. వాట్ ఈస్ ఎస్? సోర్స్ ఫ్రీక్వెన్సీ, local oscillator frequency, fs minus fl we got. So output we are getting two frequencies. One is source frequency plus oscillator, local oscillator is fs plus fl ఒకటి వస్తుంది. అవుట్పుట్ ఇంకోటి ఏమొస్తుంది? fs minus fl వస్తుంది. fs minus fl వస్తుంది. So this topic is comes under which one? Pulse radar system. We discussed pulse radar system. Again, the applications of pulse radar system. It is used in air traffic, remote sensing, military applications, safety of ships, space, and automobile traffic. So this radar range equation is expected as essay. Another question we can expect pulse radar system. And what is the basic radar system? We can expect this as a 5 marks question. Radar range equation can be expected as 10 marks question, or pulse radar system is also can expect as a one of the 10 marks question. Next we will see unit block 8 lo 3 units. 18, 19, 20. 18 is completed. Now we will see 19th unit. Different types of radars. Different types of radars. We have two types of radars here. One is CW radar, another one is MTI radar. Now we will see first CW radar, then we will go for the MTI radar. In CW radar, what is the full form of CW? CW full form is continuous wave radar. What is the full form of CW? Continuous wave radar. It works on Doppler effect principle. It works on which principle? It works on Doppler effect principle. It is used for the moving targets. What is the meaning of moving target? In previous transmitter, receiver, duplexer, this side antenna. Our moving target, transmitter, receiver, duplexer. What is this one? Antenna. Previous whatever we discussed, our final target is fixed one. What is this one? Final target. Previous whatever we discussed, the final targets is fixed one. Here the final targets is moving. So this continuous wave radar is used for moving targets, stationary targets or clusters. It is working on which principle? It is working on the principle of Doppler effect. Here, as we discussed previously, what is R? R is the range. R is the distance between the radar and target. Then the total wavelength of the two paths. Here, what is the two paths? Two paths means transmitter path and receiver path. The two paths is represented by 2R by lambda. Where what is lambda? Lambda is the wavelength, R is the range. Each one takes 360 degrees phase shift. How much phase shift? Transmitter to duplexer. Transmitter నుంచి duplexer కి వెళ్తుంది కదా ఫస్ట్ వన్. ట్రాన్స్మిటర్ టు డూప్లెక్సర్ కి 180 degrees తీసుకుంటుంది. డూప్లెక్సర్ టు రిసీవర్ ఎంత తీసుకుంటుంది? 180 degrees తీసుకుంటుంది. సో టోటల్ is 2π radians. Total is 2π radians. So total phase shift equation has to write first. Total phase shift phi equal to 2π r by lambda. How we got 2π r by lambda? Actual, what is the formula? 2r by lambda into, it is taking 2π radians. 2r by lambda into 2π. What we will write? 4 pi r by lambda. 4 pi r by lambda. What is this one? This is the total phase shift pi. Total phase shift 5. Next, what I am calculating? Angular frequency is calculated. What is angular frequency here? Angular frequency is represented with Doppler angular frequency. What is WD? What is D here? D is Doppler effect. W means angular frequency. So, calculating W. W equal to 2 pi FD is equals to d pi by dt of, so here this is the major equation. What is the major equation? W equal to 2 pi fd, which is equal to d pi by dt. Next, d by dt. What is phi? What is phi, ma? Phi equal to 4 pi r by lambda. So 4 pi by lambda is writing separately in the down equation. So the equation is rewriting as angular Doppler frequency equal to 2 pi fd times of 4 pi by lambda ni ikkada separate ga rasesam. Next, what is left? Dr by d lambda dt. Dr by dt. Here I am taking dr by dt as the radial velocity. What is here? V. V is, here I am taking radial velocity as Vr. If dr by dt equal to Vr, in place of dr by dt, what I am substituting? I am substituting Vr. After substituting again, you cross check the equation. What you will get? Angular frequency equal to 2 pi fd equal to 4 pi by lambda is writing as it is. In place of dr by dt, what is written? In place of dr by dt, Vr is written. After that, calculating frequency. That calculating frequency. Yeah. The previous equation, see here, this 2 pi, this 2 pi, this 2 times. Here this is 2 times. So what we got final FD frequency? FD equal to 2 times of VR by lambda. FD is equal to 2 times of VR by lambda. That one is written in the next step. FD equal to 2. What is V here? Velocity, radial velocity by lambda. From this, lambda is writing. Here, I am substituting the value of lambda. What is lambda? Wavelength equal to velocity by frequency. That one is substituted in the above equation. So, FD equal to 2 radial velocity by lambda. Lambda ante enta? C by F. Denominator lo undi ganaka F పైన వస్తుంది, C కింద వస్తుంది. So this is the equation of FD. We got this equation. This radial velocity is taking as a 2 components, cos component and sin component. Then in terms of cos and sin is written. VR equal to, here I am taking V cos theta, where I am substituting in place of VR. So FD equal to 2 times of, in place of VR, I am substituting V cos theta, V cos theta by C times of F. So this is here, FD equal to 2V cos theta F by C. Here I am treating theta equal to 0, cos 0 into 1. So we get FD equal to 2V by C times of FT. Suppose theta equal to 0. Theta 0 పెడితే మనకు ఒక ఈక్వేషన్ వస్తుంది. ఎందుకు? cos 0 equal to 1. Suppose cos 90 ఎంత? 0. At that time, total frequency becomes 0. At that time, this condition is when cos 9, theta equal to 90 degrees ఉన్నప్పుడు. ఇది theta 0 degrees. If theta equal to 0 degrees, we are getting equation FD equal to 2 nu by C times of FT. If cos 90 తీసుకున్నాం అనుకోండి మొత్తం టర్మ్ 0 అయిపోతుంది. So this is up to derivation part. Next we will see the block diagram explanation. Here one more important point here is this CW radar is used to determine the radial velocity of the target. This CW radar is used to determine the radial velocity of the target. Final radial velocity is from equation 19.3, where what we have in 19.3? This. Point 3. FD equal to 2. From 19.3 నుంచి radial velocity ఏమొస్తుంది? From 19.3 what we will get radial velocity is equals to lambda FD by 2. We are equal to lambda F by 8. So what is the final conclusion? Using CW radar, we are calculating radial velocity. Using CW radar, we are calculating radial velocity of the target. And radial velocity formula is mentioned here. So this is the formula of what? This is the formula of radial velocity. After this, now we will see the block diagram. First derivation part cheyali, tarvata block diagram explain cheyali. Now in this block diagram, which is input side and which is output side? CW radar is this part is input or output? This part is input. Input ante transmitter. What is this part? This part is receiver. This part is receiver. Next, what is this one? This is antenna. What is this? This is antenna. Just a rough draft I will explain here. Next we will go for it. ఇక్కడ ఏముంది మనకి? CW radar ఉంది. CW radar నుంచి ఎక్కడికి వెళ్తుంది డయాగ్రామ్ లో? CW radar నుంచి ఎక్కడికి వెళ్తుంది? డూప్లెక్స్ కి వెళ్తుంది. ఇక్కడ ఇదేంటిది? CW radar. CW radar నుంచి అది ఎక్కడికి వెళ్తుంది? డూప్లెక్సర్ కి వెళ్తుంది. షార్ట్ ఫామ్ రాసి. డూప్లెక్సర్ నుంచి ఎక్కడికి వెళ్తుంది అది? యాంటీనాకి వెళ్తుంది. సో when input is transmitting, సిగ్నల్ ఎట్లుంది? ఇటు సైడ్ వస్తుంది, ఇన్సైడ్ వస్తుంది. నెక్స్ట్ ఇప్పుడు సిగ్నల్ బ్యాక్ వెళ్తుంది. ఇది ఇన్పుట్, దిస్ ఇస్ అవుట్పుట్. CW radar to duplexer, duplexer to antenna. Here the input signal, whatever the signal is going, this is input signal. From here again the signal becomes అవుట్పుట్. ఇప్పుడు అవుట్పుట్ ఎక్కడికి వస్తుంది? మళ్ళీ ఇట్లా వస్తుంది, బయటకు వస్తుంది. దిస్ ఇస్ ఇన్పుట్ సిగ్నల్. ఇక్కడికి వస్తుంది. ఇక్కడికి వచ్చినాక ఏమవుతుంది? మళ్ళీ డూప్లెక్సర్కి వెళ్తుంది. డూప్లెక్సర్కి వెళ్తుంది. డూప్లెక్సర్ నుంచి కిందికి వస్తుంది. కింద వచ్చి ఏమవుతుంది? ఇక్కడ మిక్సర్ ఉంటుంది. నెక్స్ట్ మిక్సర్ తర్వాత ఆడియో యాంప్లిఫైయర్. నెక్స్ట్ వీ హ్యావ్ అవుట్పుట్. ఇప్పుడు చూడండి అగైన్ ఇన్ దిస్ డయాగ్రామ్. సో CW radar నుంచి డూప్లెక్సర్ కింద పెడదాం. డూప్లెక్స్ ఇప్పుడు ఇది ఎక్స్ప్లెయిన్ చేయండి. ఇప్పుడు ఇక్కడ ఏముంది? ఇది యాంటీనా ఉంది. వాట్ ఎవర్ ద ఇన్పుట్ ఈస్ పాసింగ్ హియర్, that I am taking as a transmission of FT I am choosing. What is here? FT. Next, it reached the moving target. మూవింగ్ టార్గెట్ రీచ్ అయినప్పుడు మనకి డాప్లర్ ఎఫెక్ట్ తోటి ఇక్కడ ఎఫ్డి ఉంటుంది. ఎఫ్టి వచ్చింది. అగైన్ ఎఫ్టి. హియర్ టార్గెట్స్ ఆర్ మూవింగ్. హియర్ టార్గెట్స్ ఆర్ మూవింగ్. హియర్ టార్గెట్స్ మూవింగ్, we will get FD. First input is FD. FT is passing to the duplexer. From here, after reaching here, after reaching here, what we have? FD plus FT. Again, this FT plus FT, where it is going? It is going to the duplexer. Again, with some leakage, here we have FT. ఇట్లా ఉంది కదా, ఇక్కడ నుంచి FT వస్తుంది. ఇక్కడ నుంచి ఏమొస్తుంది? FD ప్లస్ FT. రెండు లోపలికి వచ్చేసినాయి. So this FT will cancel. What you will get after passing from the duplexer? You will get only FD. After getting FD, this FD is passed to where? Mixer కి ఇస్తున్నాం. మళ్ళీ మిక్సర్ నుంచి ఎక్కడికి వెళ్తుంది? ఆడియో యాంప్లిఫైయర్కి వెళ్తుంది. మిక్సర్ నుంచి ఎక్కడికి వస్తుంది? ఆడియో యాంప్లిఫైయర్కి వస్తుంది. నెక్స్ట్ ఆడియో యాంప్లిఫైయర్ నుంచి ఎక్కడికి వస్తుంది? ఆడియో యాంప్లిఫైయర్ నుంచి ఫైనల్ గా ఇది ఇండికేటర్ అవుట్పుట్ కి చూపిస్తుంది. నౌ వి విల్ సీ ద టెక్స్ట్ బుక్ ఇమేజ్. See here, CW radar. Here input is FT. After passing FT, here I am getting FT plus, what I will get? FT plus or minus. FT plus or minus FD వస్తుంది. Again it is passed to the duplexer. ఇక్కడ నుంచి ఏమొస్తుంది? FT వస్తుంది. ఇక్కడ FT plus FR minus FD వచ్చింది. FT will cancel. ఇక్కడ ఏమొస్తుంది? మనకు ఓన్లీ FD మిగులుతుంది. This FD is plus or minus FD is passed to the mixer. Next mixer నుంచి audio amplifier the indicator. See here, what is the final output we got? Final output we got is plus or minus FD. If plus F means target is moving towards the radar. Plus sign represents target is moving towards the radar. If it is minus sign, target is moving away from the radar. This is the operation. And again writing the angular velocity. Angular velocity formula you write directly. Angular velocity is equal to lambda times of FD by 2. Just to overview of the diagram, I will explain once again in short form. What we have? CW radar. CW radar నుంచి ఎక్కడికి వస్తుంది? డూప్లెక్సర్. డూప్లెక్సర్ నుంచి యాంటీనా. మళ్ళీ యాంటీనా నుంచి బ్యాక్ వస్తుంది. బ్యాక్ వచ్చినప్పుడు మళ్ళీ డూప్లెక్సర్కి వెళ్తుంది. ఇక్కడ FT ప్లస్ FD ఉంది. ఇక్కడ మనకి ఏముంది? FT ఉంది. లీకేజ్ రెండు క్యాన్సల్ అయ్యి మనకు అవుట్పుట్ లో ప్లస్ ఆర్ మైనస్ FD వస్తుంది. దిస్ ఈజ్ అబౌట్ CW radar. Next one we have MTI radar. One other essay question we can expect. This is MTIR radar. Now we will complete this block diagram of MTIR radar. Let's see this diagram. First I will explain in the image. Next we will see step by step sentence. Here, functioning will start from here. STALO, full form of STALO is stable oscillator. What is STALO? Stable. oscillator, stable S oscillator. Next, another oscillator we have called coherent oscillator. Coherent oscillator is represented with which one? Coherent oscillator is represented with COHO. COHO. Coherent. COH means coherent. O means oscillator. Coherent oscillator. స్టాలో ఆసిలేటర్ నుంచి వచ్చే ఫ్రీక్వెన్సీని ఎఫ్ఎస్ అంటాము. కోహరెంట్ ఆసిలేటర్ నుంచి వచ్చే ఫ్రీక్వెన్సీని ఎఫ్సి అంటాం. These two are applied to the mixer 1. So after applying to the mixer 1, what we will get? FC plus FS plus or minus is mentioned. FC plus FS minus వస్తుంది. From there, it is applied to klystron amplifier. ఇక్కడ ఎఫ్ఎస్ ప్లస్ ఎఫ్సి. మనకు మిక్సర్ 1 దగ్గర అవుట్పుట్ ఏమొస్తుంది? ఎఫ్ఎస్ ప్లస్ ఆర్ మైనస్ ఎఫ్సి వస్తుంది. దిస్ వన్ ఐ ట్రాన్స్మిటింగ్ టు ద క్లిస్ట్రాన్ యాంప్లిఫైర్. ఇది ఎక్కడి నుంచి ఎక్కడికి వెళ్తుంది? క్లిస్ట్రాన్ యాంప్లిఫైర్కి వెళ్తుంది. ఇక్కడ నుంచి ఎక్కడికి వెళ్తుందమ్మా? క్లిస్ట్రాన్ యాంప్లిఫైర్కి వెళ్తుంది. క్లిస్ట్రాన్ యాంప్లిఫైర్కి పల్సెస్ ఎక్కడి నుంచి వస్తాయి? పల్స్ మాడ్యులేటర్ నుంచి వస్తాయి. రెండు కలిపి ఎక్కడికి వెళ్తుంది? డూప్లెక్సర్కి వెళ్తుంది. డూప్లెక్సర్ నుంచి ఎక్కడికి వెళ్తుంది? మళ్ళీ టువర్డ్స్ యాంటీనా. డూప్లెక్సర్ నుంచి ఎక్కడికి వెళ్తుంది? టువర్డ్స్ యాంటీనాకి వచ్చేస్తుంది. When it is reached antenna, what is the equation we will get? Input is FC plus FS. FC plus FS అనేది మనకి ఇక్కడ ఇన్పుట్. FC plus FS is input. This FC plus FS కి ఇక్కడ మూవింగ్ టార్గెట్స్ కి ఏముంటది? FD ఉంటుంది. So here what we will get finally? FC plus FS plus or minus FD was. This FC plus or minus FD మళ్ళీ ఎక్కడ అప్లై చేస్తున్నాం? డూప్లెక్సర్కి అప్లై చేస్తాం. డూప్లెక్సర్ నుంచి అది ఎక్కడికి వస్తుంది? కిందికి వస్తుంది. మళ్ళీ ఇక్కడ ఇన్పుట్ ఏంది? ఇప్పుడు ఎఫ్సి ప్లస్ ఎఫ్ఎస్ ప్లస్ ఆర్ మైనస్ ఎఫ్డి ఉంది కదా, దాని నుంచి స్టాలో నుంచి నేను ఎఫ్ఎస్ అప్లై చేస్తున్నా. స్టాలోని ఈ మిక్సర్ 2కి స్టాలో కనెక్షన్ ఉంది చూడండి. ఒక కనెక్షన్ స్టాలో నుండి ఉంది. సో ఈ ఎఫ్ఎస్ క్యాన్సిల్ అయిపోతుంది. మనకు అప్పుడు ఇక్కడ ఏం మిగులుతుంది? ఎఫ్సి ప్లస్ ఎఫ్ఎస్ మిగులుతుంది. ఎఫ్డి మిగులుతుంది. ఎఫ్సి ప్లస్ ఎఫ్డి మిగులుతుంది. ఇది ఎఫ్డి. ఎఫ్సి ప్లస్ ఎఫ్డి. అగైన్ దిస్ ఎఫ్సి ప్లస్ ఎఫ్డి ఉంది కదా, దీనికి మళ్ళీ కోహో కనెక్షన్ ఉంది. ఇక్కడ ఉంది. ఎఫ్సి ప్లస్ ఎఫ్ఎస్ అనేది ఇంటర్మీడియట్ యాంప్లిఫైర్ నుంచి ఇక్కడ దాకా వచ్చేసింది. మళ్ళీ ఇక్కడ ఇంకొక మిక్సర్. ఈ మిక్సర్ ని ఫేజ్ డిటెక్టర్ అని కూడా అంటాం. ఇప్పుడు ఇక్కడ నుంచి ఏమొస్తుంది? కోహో నుంచి మన కోహరెంట్ ఆసిలేటర్ నుంచి ఎఫ్సి వస్తుంది. నెక్స్ట్ ఈ ఎఫ్సి క్యాన్సిల్ అయిపోతుంది. మనకి ఏం మిగిలింది? ఫైనల్ గా ఓన్లీ ఎఫ్డి మిగిలింది. ఇక్కడ మీకు అవుట్పుట్ ఏముంటుంది? ఇక్కడ ఎఫ్డి ఉన్నది. నెక్స్ట్ ఇఫ్ ఎనీ డిలే ఇన్ పాసింగ్ ద సిగ్నల్ వి విల్ యూస్ డిలే. ఇఫ్ మనకి సిగ్నల్ పాస్ అవడానికి మన డిలే ప్రొడ్యూస్ అవుతుందో చెక్ చేస్తాం. బోత్ ఆర్ యాంప్లిఫైడ్ అండ్ సబ్ట్రాక్టెడ్ టుగెదర్. ఇక్కడ ఎక్స్ప్లెయిన్ చేస్తాను. ఫస్ట్ చెప్పండి, స్టాలో నుంచి మనకి ఏమొస్తుంది? ఫ్రమ్ స్టాలో ఎఫ్ఎస్ వచ్చింది. ఫ్రమ్ కోహో ఎఫ్సి వచ్చింది. ఈ రెండింటిని దేనికి అప్లై చేస్తున్నాం? మిక్సర్కి అప్లై చేస్తున్నాం. అవుట్పుట్ ఏమొస్తుంది? అవుట్పుట్ ఈస్ ఎఫ్సి ప్లస్ ఎఫ్ఎస్ వచ్చింది. అవుట్పుట్ ఏమొచ్చింది? ఎఫ్సి ప్లస్ ఎఫ్ఎస్ వచ్చింది. ఈ ఎఫ్సి ప్లస్ ఎఫ్ఎస్ ని త్రూ డీప్లెక్సర్కి ఎక్కడికి అప్లై చేస్తున్నా? యాంటీరాకి పంపించిన. ఈ యాంటీరాకి పంపించినాక మనకి ఇక్కడ ఏమొస్తుంది? ఎఫ్సి ప్లస్ ఎఫ్ఎస్ ప్లస్ ఆర్ మైనస్ ఎఫ్డి వచ్చేసింది. ఎఫ్సి ప్లస్ ఎఫ్ఎస్ ప్లస్ ఆర్ మైనస్ ఎఫ్డి వచ్చింది. మధ్యలో మనకి ఇక్కడ ఏముంది? డూప్లెక్సర్ ఉంది. మళ్ళీ ఇది బ్యాక్ డూప్లెక్సర్కి వస్తుంది. ఇప్పుడు చూడండి, మనకేముంది సిగ్నల్? ఇన్పుట్ సిగ్నల్ ఇప్పుడు ఏముంది ఇక్కడ? ఎఫ్సి ప్లస్ ఎఫ్ఎస్ ప్లస్ ఆర్ మైనస్ ఎఫ్డి ఉందా? దీనికి నేను ఇక్కడ ఏం చేస్తున్నాను? మిక్సర్లో జాయిన్ చేస్తున్నాను. ఈ మిక్సర్లో ఫస్ట్ దేని అటాచ్ చేయాలి? స్టాలోని అటాచ్ చేయాలి. స్టాలో అంటే ఏంది? ఎఫ్ఎస్. ఇది ఎఫ్ఎస్ క్యాన్సిల్ అయిపోతుంది. నెక్స్ట్ ఏమొస్తుంది? ఎఫ్సి ప్లస్ మైనస్ ఎఫ్డి వస్తుంది. మళ్ళీ దీన్ని ఇంటర్మీడియట్ యాంప్లిఫైర్కి అప్లై చేస్తున్నాం. Again, this is applied to which one? Again, this is applied to intermediate amplifier. Intermediate amplifier కి అప్లై చేసినాక నెక్స్ట్ ఏం చేస్తున్నాను? మిక్సర్ 2. Either you can call mixer 2 or phase detector. మిక్సర్ 2 or phase detector కి వస్తుంది. ఇప్పుడు మనకి ఇక్కడ ఇన్పుట్ ఏముంది? స్టాలో కట్ అయిపోయింది. ఎఫ్సి ప్లస్ ఆర్ మైనస్ ఎఫ్డి ఉంది. ఇక్కడ నుంచి నేను ఒక ఎఫ్సి పంపిస్తున్నాను. This FVC is cancelled and we are getting what output we are getting? Plus or minus FD got. If maybe the signal is delay, the two signal delay frequency రెండింటిని subtractor use చేసి output we are collecting. We will collect output. So this is the overall functioning of the diagram. Now we will see the same thing in step by step in textbook how it is explained. This diagram. MTIR radar. So it is a combination of both pulse and Doppler effect to improve the performance and to measure and measurement capabilities. And it is using improving the performance and this measuring capabilities also improved. This radar system is specially used for which one? This radar system is specially used for moving target objects or moving MTI radar. MTI full form in the moving target indication radar. Moving target indication radar. It is specially used for moving targets. The targets are moving from one place to another. Means the targets are not stationary, fixed okka daggara unde anamata. So for those stationary targets, we have to calculate what? We have to calculate the relative velocity of the target. Relative velocity can call target. The next MTR radar system is a set of received echoes with those of received echoes during the previous sweep. So our noise is compulsory is there. Those noise term we are calling as echoes. From moving to one to another, those noises sometimes it will be cancelled. Next, what is explained in the explanation part? What is STALO full form? Stable local oscillator, which is it is represented with what? FS. FS. Next, what is coherent oscillator, which is presented with FC. These are where we are combining these two. We are combining these two in the mixer. After combining in the mixer, what we will get? FS plus FC. This FS plus FC again is feeding to where in the diagram? So we are applying to the Doppler effect. After attaching to the Doppler effect, we will get FS plus FE plus or minus FD. This one is giving to the mixer 2. After giving to the mixer 2 came this star connector in the children. In the diagram to the mixer 2, which is connected. Mixer 2 key. In the diagram to the mixer 2, Stalo is connected. So Stalo and FS. FS is cancelled. After Fs is connected, what you are getting? Fc plus or minus Fd. Again, it is further amplified by the intermediate frequency, intermediate amplifier. After that, I am connecting to another mixer 3. This mixer 3 here is represented with what? Phase sensitive detector. After connecting to the phase sensitive detector, coho signal is also connected. So coho FC cancel outundi. Finally, what you will get? You will get plus or minus FD. This plus or minus FD is called as Doppler frequency shift. Especially this is using for which one? Especially this is used for moving targets. Next, here again we are calculating the time period. What is PRF? Pulse frequency. What is PRF? We discussed this one in the previous only. Pulse reception time or pulse receptor frequency. What is PRF? P means pulse receptor frequency or else pulse reception time. So we are calculating the time period. Time period is equals to 1 by pulse receptor frequency, 1 by PRF. Why we are using delay line in the diagram? The delay line is used to introduce this time period dt. Delay and undelayed signals serves as an input to the subtractor. ఇక్కడ మనకు subtractor ఉంది diagram లో. To this subtractor, one input is after producing the delay. Another input is without applying the delay. These two are applied and we are getting final display output. This so in this unit 19 or block lo second unit lo, we can guess two essay questions. One is CW radar, another one is MTI radar. These two can be expected as a 10 marks essay question. Another essay question in this is radar range equation. Now we will see which is comes as a short, which can be expected as a essay questions. What is the first one we discussed today? Just I will write the list of what we discussed today. First, we discussed different types of radars. What is different type of bistatic and monostatic? Bistatic. Another one is monostatic radar and diagrams is discussed. Next, we discussed about radar range equation. Radar range equation. This radar range equation can be expected as a essay question in the from previous year questions. Next, what we discussed after radar range equation? Pulse CW radar. Pulse radar. These three comes under unit 18. These three comes under which one? These three comes under unit 18. In unit 19, we discussed two essay questions. What is the first essay question? CW radar. Another one is MTI radar. These also two comes as a can expect 10 marks question. Now we will see the which questions from this unit is covered in essays and short. Recent supply exam question paper we will see from this. This is the question paper of 2025 January, recent question paper. In this, see, explain the detailed working explain the detailed working of continuous CW radar. Continuous CW radar as a essay question from this today's discussion. And in short, which one is covered in short from this unit? Describe the working of pulse radar system. Today we discuss this one. This is came as a 5 marks question and that one 6 marks question. We will see another paper and we'll cross check. Which is essay question and which is short question. This short, here we have essay question. Here the essay question is, draw the block diagram of continuous wave radar and explain its working. It is a essay question. In this, which is came as a short question, using block diagram, describe the working of pulse radar system. This is a short question. This is the 2011 question paper. And we'll see one more question paper. In this, from this unit, what we discussed from that, which is essay question in, can guess anyone? Which is essay question? Describe the working of pulse radar system. This is as a one of the essay question. In this, which is a short question? In this, which is short. Write a short note on. Write a short note on basic radar system. Write a short notes on basic radar system means what are the things has to cover? Monostatic. Another one is bistatic radar system, and explain the both the features and differences. It comes under bistatic radar system. Next we will discuss in tomorrow's class what is different tracking systems. We can expect that tracking systems as a short only. We will see in the next class. We will see the tracking radars. Just I will start the introduction for the tracking radar. Tracking radar. In the tracking radar, we have 3 types: sequential lobbing and canonical scan. And another one is monopulse tracking radar. We will see that one. Monopulse tracking radar. Just I will give the introduction and we'll stop. What are the topics we will discuss in the next? What is that one? First one we will discuss sequential lobbying. Second one we have conical scan. Second one is conical scan. Third one we have monopulse. Scanning. In sequential lobbying, we will discuss these 3 in tomorrow's class. This class is completed.